So now on this slide, we're going to start to practice. If I take a test tube of this substance and a test tube of that substance, what do I get? Do I get a reaction or not? So we're going to break that down into a few steps here. So first of all, I'm going to consider these two substances and figure out what the product's formulas might be. So if I check back to my solubility rules, that was this sheet, then I can see that these would both be aqueous. So they're going to divide up into ions. And we've been practicing, so we know that the ions they would break up into are these ions. Don't worry about the subscripts, I just want to know what ions I have. Now, when those recombine, I want to think about what substances they'll make. So the iron will trade with the sodium. So we're going to end up with NaNO3 and iron with the carbonate, so FeCO3. So that is the chemical formulas of the possible products of this reaction. Now I want to look at phase symbols for each reactant and product. We already did that for the reactants. If I go look up sodium nitrate, I would find that both sodium and nitrate always stay aqueous, and then iron carbonate, I would find out that carbonates are insoluble, so that means that they would be solid. So that was doing the work of box B by putting those phase symbols on. So now we're going to write out the full chemical equation. So I'm going to start with those reactants. Iron nitrate aqueous plus Na2CO3 sodium carbonate aqueous gives me NaNO3 aqueous plus iron carbonate. It doesn't matter if I flip-flop those products or reactants, they just have to stay on their sides. And just to help me see it, I'm going to color in this solid substance, and everything else is aqueous. So those are going to be ionic compounds that can break up. So next we're going to do something that we've done before. We're going to balance this. So I see 2 nitrates and just 1 over here, so I'm going to double that, which doubles my sodiums, so now I'm balanced. Now I can write the full ionic equation. Anything aqueous gets broken up, so iron 2 plus aqueous plus 2 nitrates, that's 2 nitrates aqueous plus 2 sodium ions plus carbonate ion turns into 2 sodium ions plus 2 nitrate ions. Here that 2 is going to distribute to both of those. And I don't touch my solid. That stays solid. I can't break it up no matter what. Next step, like we've done before, we want to look for spectators, the ions that don't change on either side. So 2 sodiums will cancel, 2 nitrates will cancel, and then it's just a matter of copying down whatever's left over. So iron ions are going to combine with carbonate ions, and that gives me iron carbonate solid, and I'm just emphasizing that's a solid, I never broke it up. So I took 2 chemicals, broke them into ions, figured out what products I would have, put that all together in a reaction, wrote the full ionic equation, and then distilled it down to the driving force, the important piece of it, the net ionic equation. So you're going to have the chance to do more of that on your next slide. Bring that to our lecture conversations or practice it now. And then you will have another chance. This will be like one of the labs that we do. So we'll work this one out together. So this one's a little bit different. This time I have copper metal, which is the same as saying copper solid. And then my other substance is silver nitrate, which if I look it up, is not solid, but is aqueous. So this is a solid right off the bat, like copper that you would have in a penny. No ions there. This I can break into ions, silver plus and NO3 minus. Copper, however, can turn into copper 2+ ions. So that information would be given to you. And now I want to recombine things. So the copper would be able to combine with the nitrate, and then my silver would actually just be left alone, and it would end up becoming a solid. And I would see this in a single displacement reaction. So phase symbols, I already told you this was going to be solid, and we'll see more reactions like this. Copper nitrate, look it up on your solubility rules. Nitrates are always aqueous, so that's going to break into ions. So you're going to want to write the full chemical equation, full ionic, and net ionic. So let's check that out. So I'm going to start with that copper metal, or copper solid. I'm going to combine it with silver nitrate, which was aqueous. I will get silver solid, and then this other product here, copper nitrate, and the copper nitrate is aqueous. Next I need to balance it. I notice the nitrates are out of balance, and then my silvers. So balanced. Now I'll go ahead and write the full ionic equation. Remember, I have some solids here, so I can't touch that copper, and I can't touch that silver. So full ionic equation will look something like this. Go ahead and work it out. So there's our full ionic equation. Notice I've still got those two solids hanging out here. And now I'm ready to cancel spectators out. You might at first glance think, hey, I've got two coppers, but this one's solid and this one's not. It's an ion, it's aqueous, so those are not going to cancel each other out. Only thing that cancels are the two nitrates. And so once those have canceled, I'm ready to write my net ionic equation. Copper solid plus 2 silver ions gives me 2 silver solid plus copper 2+ aqueous. And essentially what happened in this reaction is copper gave some of its electrons to silver, and in the process silver became solid. This is called an oxidation reduction reaction, and it's what's happening in